jump into our next topic here on insulation. So now that we've sealed the air leaks, we're going to look at how we use insulation to keep the heat where it should be. Okay, so we'll start by looking at different types of insulation. We'll look at how we determine how much insulation we need for any application, and then we'll look at some installation tips and guidelines when you go to install it. And we'll talk about some of the cost analysis as well. So just to kind of recap, basic purpose of insulation is to keep heat where it should be. So that simple picture there on the left, it shows in the winter time it's cold outside, and in this picture it's just showing insulation up in your attic. And so all that insulation is doing in the attic, it's keeping heat inside your home so that that cold winter temperature doesn't get inside your living space. It's the exact opposite on that right-hand side. With the sun shining down on your roof, you're trying to keep the hot air outside. And so your attic might heat up to some extent, but the insulation there on your ceiling is keeping that heat from the sun from going all the way down into your living space. So regardless of whether you're talking about heating and cooling seasons, it's kind of serving the same purpose. It's stopping the flow of heat. So now that's on a very basic level, but we'll talk about just 4 different ways that heat actually moves through an environment. Like how does heat move through your home? First, it happens by infiltration. We just spent the last bit of our program talking about air infiltration and how we stop that with air sealing, caulking, weather stripping, and that kind of thing. Insulation is not really going to help with that. Radiation is directly from the sun, and that's the actual movement of the energy from the sun. And so you'll feel that on a nice hot summer day. You can stick your arm out and feel the radiation on your skin. Convection is the movement of air. And so this, I guess the best picture I could think on the top of my head is putting your hand over a boiling pot of water. If you're boiling a pot of water on the stovetop, put your hand over it and you'll feel the heat rising up from the hot boiling water. And then, of course, if you actually touch the pot itself as it's boiling, then there'd actually be a point of connection, which is what we call conduction. Okay. And so I know that's kind of a lot if you're not familiar with this, but conduction is really when you have 2 solid objects touching each other. And that's really what insulation does. It's a solid material that goes in your roof or in your attic space, in your walls, or in other places, and it stops the flow of heat through that solid material. And so, if you have a wood house and the heat is penetrating that wood, and then you have an insulation layer somewhere in there, and so you're stopping that heat from going all the way through the wall, for instance, and that's by conduction. And so to answer the question I asked earlier, the R value, the R here stands for the resistance. Okay, so some of you got that question right, so I applaud you for that, but the resistance to heat flow is really what we're talking about when we talk about the R value for insulation, and we'll look at some specifics for that momentarily. There are various types of insulation out there. I'll briefly give a few comments on each. The batting blankets or rolls that we're probably familiar with. There's a picture there at the top right to show you what that looks like. But that's just something you unroll. It'll lay between your studs, pretty standard spacing on that and dimensions for that. So it's pretty quick and easy. Especially for a do-it-yourself install. That's easy to put out there. I'll talk about some things to be on the lookout for when you're going to install it and make sure it's installed properly, but that's pretty easy to work with. The blown-in insulation you could do it yourself, but typically you have a contractor come in and they use that big hose and it blows the small fibers and chips into place. Often used in attics. It's easy. You could do it into a wall as well. The benefit for blown-in insulation, all the small particles and fibers and pellets, they go into hard-to-reach areas. They fill odd-shaped gaps and cavities that you might not be able to get that that big roll of foam into place. Spray foam insulation is similar in that you can spray it and apply it to hard to reach areas and hard to fill gaps. You'll see there they're spraying it on the right hand side. If you can see, they're spraying it between the studs rather than batting. So it's just another option there. The benefit to spray foam, again, we've talked about it kind of in terms of air sealing. It is also used for insulation. It expands and it fills a gap that it's sprayed into. And so there's some benefits there. You have to be careful working out around windows and other stuff that it doesn't expand and cause problems around the window. But it can be used in a lot of areas and a lot of hard to fill gaps. So there's some benefit there. And a lot of them do act as a vapor barrier as well. And so there's a benefit to that. Spray next as rigid foam. So if you buy a foam board or a sheet of foam, you'll typically see these on a foundation or in the basement walls. And these are quick and easy to put up. There's all different types of materials you can use for it. But that rigid foam is just a big sheet of foam that you can put in place. Again, this has a benefit of more vapor protection. And so that's why another reason why it's good for basements is you can put it there and it'll manage some of the moisture a little bit better. And then there's the specialty products. We're not going to talk too much about that today. We've talked about it in previous sessions when we looked at insulation around hot water heaters or piping and air ducts. You can buy specialty products for that as well, but we're primarily going to talk about the other types. Now, when you are assessing the insulation in your home, you might be considering if you need to update it or add to it to reach appropriate levels. First thing you'll do is try to determine what type you have. I've included a little guideline here for those of us that might not be as familiar with the material as others are. But if you have any of those small pellet pieces or anything, you might have to poke around in your attic to find it. The smaller particles are typically the blow-in materials. And there's some guidelines here and the difference between fiberglass and mineral wool, cellulose. If you're not sure, you can also do some investigation online and find out what it is. If it's something in your wall, it's a little harder to see. One way to kind of find out what's in your wall is to take off the light switch panel, and you can sometimes you can kind of peek around the light switch enclosure and see what kind of insulation you have in the wall. But in any sense, if you can determine what it is, you'll be able to see what the R value is and get a better idea of if you need to make any improvements or not. So there's that older vermiculite and perlite that you might have, bat foam, fiberglass insulation there in the picture on the left. That bat insulation is laid up between the studs again. And then you might have spray foam insulation in various places around your home. There's some average R values included there. You might have specifications on your product itself if you're looking at it, and we'll see some of those later. But on average, I'm going to go through this example on the right hand side. If we found that we had bat insulation in our attic, for instance, it has an average R value of 3.2. So the resistance is 3.2 per inch. Okay, so if it's thicker, you're going to have more resistance. You're going to have more insulation, and so the thicker that you have it, especially if you have multiple layers, you're going to have more resistance to that heat flow, which is better because it's protecting from that heat transfer. So in any case, in this example, I'm looking up in the attic. I have an R value of the bat insulation foam is 3.2 per inch. I need to know how many inches it is. This comes pretty standard for the bat insulation. But if you have a blown-in insulation, you could use a ruler and measure how deep it is. In this example, I'm assuming it's 10 inches. So multiplying the R value by 10 inches, that gives me an R32. So the insulation in my attic in this example is R32. It's just the R value times the depth. And that's how much insulation you have. Now you could compare that to the recommended values for your area of the state and see if you're where you should be, and we'll talk about that in just a moment. But that last figure there on the bottom right, I just want to point out again, if you have multiple layers of insulation, you get the benefit of each layer. So those R values just add up. I didn't include an example here, but you just add up the R values in that case. So what are the recommended values? They're really based on the climate zone that we're in. So most of Maryland is in zone 4, and there's some R values recommended for that zone. I will say, you know, the Garrett County, Allegheny, and Washington County, where I'm at, a little bit colder out here in Western Maryland, and those are in zone 5. So there's a little bit different recommendations for zone 5, but most of us in Maryland have zone 4 recommendations. So I've included those on the table in the bottom right. You can see recommendations for zone 4. For the ceiling and attic, for instance, it's recommended for insulation R49 for your attic. And there's some other recommendations for different areas. If you want more information, you can go explore on the Department of Energy website, U.S. Department of Energy, or you can go to the Maryland Energy Administration website, and they have some more information on those R values as well, more specifics on that. I do want to go through some quick cost assessments here. When you are looking at different types of insulation, perhaps you're considering like a fiberglass batt insulation compared to a spray foam. And if you're looking at it from an economic standpoint, obviously they have different applications and are good for different environments and locations. But just from a cost standpoint, it's best to compare different insulation types based on their cost per R value. Okay, so if you're just comparing the cost of you know, batt insulation to spray foam, for instance, they provide different R values. And so you don't want to just compare the cost for the product itself. You want to look at, am I getting the R value that I want? And so this is what I've highlighted in red at the far right of the table is the cost per R value. And so for the attic, for instance, again, we want R49 in the attic in Maryland. And so if we are aiming for that, we're going to see how much it costs per R value, regardless of what type of insulation you use. And so I've just included some rough cost estimates there. You might find different costs in your area, but I just put this together. Material cost, if you're doing it yourself, you're only going to be interested in that material cost. I've included the installed cost of labor and materials in that installed cost column. If you're having a contractor do it, all I've done here to determine this is divide the installed cost by the R value of that material. That way I know how much I'm paying per R value. And so regardless of whatever R value I'm reaching, I can get, you know, an R49 with whatever material I want, and I can compare those on a cost basis. The other example there that I have on the far right is just how much insulation you might need in order to get that R value. So I've gone through an example here, and I'll just run through this real quick. You can review it on the recording later if you're interested. But most products will have recommendations for how much you need for a specific R value. And so I don't think you can make out the values given here on the label, but that photograph shows the back of the product here shows, this is a blown-in cellulose, I think, a product, if I'm not mistaken. It says 25.8 bags of insulation needed for R49. So 25.8, you're going to need 26 bags, essentially, if you're going to reach that R49. This is given for 1,000 square foot, okay? And that works fine if your attic space is exactly 1,000 square foot. But if you have a different size attic, like in this example, I'm using 1,800 square feet, you're just going to run through this quick calculation. It's 1,800 square feet, your actual attic space, divided by the reference that they give you. And if you run the numbers on that, you come out to 46 bags of insulation. So that's another way to kind of look at the cost. You know, you're going to need 46 bags of insulation. That adds up. So that's one way to look at it. Quick payback on this, simple payback on it rather. And I know this is kind of convoluted math. If you're not interested in this, that's fine. You can just tune out the next minute or so, but I'll run this through this really quickly for anyone that's interested. Simple payback, This is a rough estimate. It does not take into account factors like changing energy prices. So the price that we pay for energy today is going to be different in a year from now. And this doesn't take into account all those kind of factors. It's just a simple estimate of your payback period for insulation. And so I'll run through the top of the equation here. Starts with the installed cost that you're quoted from your contractor. In this case, I'm using 25 cents per square foot. Your initial R value is whatever existing insulation you have. So I'm assuming it's an R27 already in the home. And then I want to bring that up, in the case of an attic, I want to bring that up to a final R value of 49. The last parameter there on the top is a Greek letter there for the efficiency, percent over 100. Okay, this goes back to 2 weeks ago when we looked at heating and cooling systems. If you look at that energy guide label, that yellow label that's attached to any heating and cooling system, it gives you the efficiency of the unit. Go back to our session 2 weeks ago to see that. That's the AFUE rating for a furnace in this example. So it's 82.7%. You divide all this by those numbers on the bottom, price for natural gas. Assuming I'm using a natural gas furnace in this example, there's the price per BTU. Again, go back and review any of this heating and cooling information from 2 weeks ago if you're interested. You take the difference in your R values, you multiply it by your heating degree days based on your climate zone. I've included data here for Oakland. You could pull up your heating degree days online if you're interested, but I've included Oakland here at 6,097 and multiply by 24. If you run the numbers on this, you get a little over 12 years for the payback. So a quick estimate, and that's all I'll say about that. I want to make sure we have time for some of the other topics this afternoon. Okay, quick tips on this. Don't go right into putting the insulation in your home. Make sure you do some assessment beforehand, assess any moisture problems. You might have missing areas, you might have moist areas that need to be replaced and addressed so you don't have continued problems. The electrical issues I've shown here in the attic, improperly handled wiring, that's not to code and wouldn't pass inspection. So you'd want to address those electrical issues before you add insulation. Sealing any other air leaks, like we've talked about at the beginning of our program today. Vapor barriers should be below all of your insulation layers. You can use paint on your bathroom ceiling. You can use the vapor barriers below the insulation. Make sure none of the vapor barriers are sandwiched somewhere in the middle. If you have multiple layers of insulation, you don't want that vapor barrier in the middle somewhere because that'll trap it in the middle and it'll diminish the performance of the insulation. And then we have, ventilation, again, revisiting that topic that we touched on earlier. Make sure that you have proper ventilation in your attic. And I could connect you to some guidelines for that if you are exploring that. I've mentioned earlier as well, any vents that you have from the bathroom or kitchen should not be released into the attic. They should all of your bathroom and kitchen vents should go to the outside. So make sure those are properly sealed as well. And then you can go and add insulation in. And I'll share some quick examples here of tips that I can share with you. You don't want to have it compressed. It's not going to work. And so that top left shows fiberglass insulation batting crammed into a spot there. It's not going to work that way. Gaps between, if you're down in the basement, you see insulation in the floor, you have a gap there in that top center picture, and that's going to allow airflow in there that will cause problems. It's not going to work as intended. The bottom left, you have insulation down in the basement or crawl space, I think, and it's a moist environment, and that roll back blanket insulation, it's not going to work. You'd need that rigid foam or something else in that area. Bottom center has some voids. If you're doing a blow-in insulation, make sure you get in all the nooks and crannies. That far right on the bottom has a polyurethane foam that is a better way to address those corners. But whatever you use, make sure it gets to all those void spaces.